Welcome to episode 9, Crowd Simulation. My name is Arnold Falder and today I'm going to show you how to set up the crowd simulation module for 3ds Max, how to create delegates, how to assign behaviors to them, and how to edit multiple delegates at once. So let's get started. I'm gonna do everything in top view right now. So let me maximize my top view and get rid of the background grid. Two things you need for creating a crowd simulation in Max, and you find both of them under Create Helpers. Fifth button here, and the two items are the crowd object and a delegate. So let's first create a delegate. When you click and drag, you can see the numbers increasing there. So I'm going to create a delegate that's around 2 or 3 units big, but doesn't matter. Only when it comes to speed, then it matters. The next thing is I need a crowd object, and you can place the crowd object wherever you want. You can also drag it up to a certain size. It doesn't matter where it is. It's a dummy that you have. So here is my delegate. Let me give my delegate a strong color that you can see, something bright. Good? Yeah, not too good. So let's do there's a bright orange. And here's my crowd object, and here's my delegate. Let's have a look at the crowd object. When you select it and you go to modify, you can find all the settings for the crowd object. Very typical are also the 6 tabs up here, of which we use 2 or 3 of them. And also something that is different from the particle systems, because the crowd object is actually a simulation where you define the behaviors right here, and then you solve it. That means it takes the behaviors and solves it, and then at the end you end up having an animation with every key. For every frame there is a key. So the first thing is I'm going to take my time line here and make it a little bit larger, because 100, that's only 4 seconds. So let's hit time configuration. I'm using PAL, that's 25 frames per second, and I'm going to use a 300 frames of animation. So also here under solve, where it says start solve and end solve, I'm always solving for the whole 300 frames. So let's switch that also. But that's not the most important thing right now. So let's get started with something more important, and that is having more than one delegate. It's called a crowd simulation, and not only simulating one delegate. So let's take the delegate, select it, use the move and shift button, and make I don't know, let's make 14 copies. So I have 15 in total. Here's 15 delegates. Right now they're all standing in a line. 15 delegates, and let's give them an object that they can seek, and I'm going to use also another helper, a dummy, and place it right here in front of them. So the dummy, what they do is they seek the dummy. Basically they seek the pivot point, the center of the dummy, if they do something. So we have our delegates, we have our crowd objects. Let's create our first behavior. So you select your crowd object, go to modify, and up here you find behaviors, and I'm going to create on a new behavior, and that's a seek behavior. So the seek behavior tells them where they should go, what object they should seek. You can either use one object or more than one. So there's a select or a select list, multiple selection. I'm only selecting one, so I click on none and on my dummy. So here's my dummy 1 now, the seeking, the target of the seeking. If you have more than one target, objects will only seek the closest or average of targets, but usually the closest target only. I only have one target. That looks pretty simple. So I have a behavior. It's called seek, and I have my delegates. Now I have to tell the delegates that they have to follow the behavior, and that is here. It's called behavior assignment. So when you open up behavior assignment, opens a window that has all the delegates in the list, that has all the behaviors in the list. So only one. And you can assign delegates to behaviors. To make it a bit simpler, I'm going to put all my delegates 1 to 15 into a team. So I can address them as team 1 or team something, and then I can only assign it to a team. So let's create a team over here on the right side. I'm going to create a new team that holds all the delegates. Okay, I'm going to call it team, not team 0, but team all. And now I have my team all here on the left side. I have the seek behavior. And to assign the behavior to all the team is here this button, and then creates a behavior assignment. Behavior assignments can be active or not active. So if you have more than one, you can temporarily turn them off or inactive. For right now, I only have one behavior, and then I hit OK. So now they all know they have to find the dummy. And they have 300 frames time, and they have a certain speed. Let's solve it. So you make sure it's 0 to 300, and your timeline is 300, just to see a little bit, and then you hit solve. And then it solves the simulation. It's pretty fast. It's just 15 delegates. And now you end up with an animation. So if I now select any of the delegates, you can see I now have a position, rotation, and scale. No, not scale, I think only position and rotation. Key at every frame, something that you couldn't do by hand or wouldn't do by hand. But you can now see they all seek it, and when they find it, they just, because they have a certain acceleration, then they just continue going further and so on. So they just circle around the target. If you, actually, a few things I don't want. I don't want them to go through the target. That makes no sense, because if there will be a solid target, they should avoid going through it. Also, I don't want the delegates to get so close together. So they like really close together. So in the next case, I'm going to create a second behavior, and that is an avoid behavior. They should avoid each other. They should not get too close to them. So let's create a new behavior. So here it is, new, and we're going to use the first one, avoid. What should, if you assign the behavior to every single delegate, and you have to tell him what does he need to avoid? He needs to avoid all other delegates. So basically the behavior means avoid all delegates and avoid the target, because you don't want to get too close. So have more than one object for the avoid behavior. So I'm going to click here on the multiple selection button, and I select all delegates plus the dummy. They should all be avoided. I know that sounds a little strange. First I tell him to seek the target, but the avoid usually doesn't mean they don't go there, but they usually stay away a certain radius. So there's different. There is a look ahead radius. So if they're closer than 30, they not necessarily go there, but they never go closer than 1. And you can adjust those settings. But let's first, before we solve it, we have to assign the behavior to all the delegates. So here's my behavior assignment. Now we have two behaviors, the avoid, all team, team all, and assign it. So now they know while they are seeking for the target, they also avoid each other, so they don't get too close to the neighbors, and they don't get too close to the target. Let's solve it. So they still go there, but you can see they avoid getting too close. And here it is. So you can see they hardly touch each other. So they're really avoiding each other, and maybe a little bit too much, so we can adjust the radii. But that is quite a good distance here. Next thing is, if I look from the front, you can see they all stay on the XY plane. So here in the front, if I play the whole sequence, the whole animation sequence, yes. Now they're standing in line. We're looking from the front, so we see them going away from us. And now when I hit play, they all stay on the XY plane. That is strange because they are avoiding each other. So the best way to avoid each other would be to go up into a third dimension. But the problem is every delegate has certain parameters. Let's have a look. If I look, we're back in the top view and I'm selecting one delegate, and here you can see his parameters. So has a speed, it has an acceleration, how fast it makes turns, and so on and so on. And one of the parameters is also constrained to XY plane. So they all stay on the XY plane. If I unclick it, they are allowed to leave the XY plane, but now I have to select every single delegate and make sure they constrain. No, when you have like hundreds of delegates, you don't want to edit them one by one. That's why in my crowd object, I have a button for multiple delegate editing. So you can edit multiple delegates at the same time. Here it is. First, you define which delegates you want to edit. So add, let's add delegate 1 to 15. Select, so they are in the list. Now, when you select something, for example, I want them not to be constrained to XY plane. So I unclick it, and to make sure it's set, I have to click set. Because only the ones where set is clicked are applied to all delegates. On the other hand, I don't want them to all have the same speed. That's why here is the average speed of 5. I want it random. That means I have two values. So let's go for between 3 to 5. Now everyone gets an initial average speed between 3 and 5. If I hit set, once I hit apply, they will be applied to all delegates. So now they all have different speeds and they are allowed to leave XY plane. It might happen that they don't do, but let's check it out. Solve and go. So now, see, they don't leave the XY plane. There is a little bug there in 3ds Max or in the solver. If you're, okay, let's look from the front and you see they are still staying on XY plane. So the reason being, they are allowed to leave. If I now select a single one, you can see the constrain button is turned off. When they are standing all, the initial position is on the plane, I don't know why, but they don't leave it for a certain reason. So let's select every second one. Did I? Yeah, I'm not sure if I picked, and move them up in space a bit, and I select every other second one and bring them down. So I make sure they are away from X and Y plane. The initial position is not on the plane, and now when I solve it again, you can see they now swarm like fish in the water or bees flying around the target or something like this. So only if they are all initially on the XY plane, they stay there. But if they are not, then again, I'm looking from the front now, and now you can see that they are, as they are on different positions, not on XY plane, they also go up and down. So see, they go up and down. Although they like to stay on the X and Y plane. Why? Because their target is also on the X and Y plane. So if they don't have to, because they are avoiding something, they like to stay on the plane. Okay, makes sense? Good. Then let's do, again, I'm looking from the top. Let's do something else, and that is I'm now animating my target. So I don't leave the target where it is, but I'm moving it around in time. I can do different things. I thought about, let's do a path. So here's a line. So close the splines. Here's a simple animation path, and now I'm going to take my target, my target of the object, and make it move along the spline. How did that work? So you select your target, you go to animation constraints and path constraint and click on the path. So now the object will move along the path. You can see that the delegates are still doing their old thing. Why? Because we haven't solved it yet. So now their target is being taken away from them. So when we solve it, select it and select and modify and solve it, they will of course follow the animated target. They are still avoiding a lot, so maybe the avoid behavior could be a bit smaller. Let's make it only 15, so they're not looking that far ahead for a object to avoid. So let's see, they now should be a little bit closer together to my target. Okay, so here it is, and you can see in 3 dimensions. And let's hit play. Okay, and they're all following my object. Maybe I should make them a bit faster, some of them, but the rest is good. Okay, so that is 2 behaviors assigned on the objects. Now let's do a new crowd object, and I'm going to show you a few more options. The rest you can go through them, and I'm sure there's also tutorials how to work with every single one of those behaviors. But what I would like to start, and I'm going to do a quick reset. Don't save. Yes, reset. I would like to do I show you the scatter, how to scatter delegates evenly on a surface, and therefore I need a surface. So let's do a quick surface. I'm going to get a plane. I'm going to use a simple plane. And as I would like to make a couple of mountains here, I am going to give it a lot of segments. So let's try 30 by 30. Yeah, maybe even more. Let's do a 60 by 60. So I got plenty of segments there. Different ways to create some mountains. I'm going to choose the right-click, convert to editable poly, and in the poly editing there is a when you go into a polygon and the polys, for example, there is the all the way down. Sorry, edit polys. I missed it somewhere. Editable poly, and what I'm looking for is, yeah, sorry, it's minimized here. All the way down, paint deformation. Push and pull. I'm going to use the push and pull tool, and let's paint over it. So if you paint, you could create a mountain, but that is too high. Undo. So the brush size can be larger. Let's make it 40, and the push pull value is too much. Let's go 5. So let's just create a simple terrain. So there it is. And quite a big mountain. So let's push that back in again. So good, crater, and out of the push and pull tool. So let's create delegates, and I want those delegates to run around like, like ants on a hill or like on a terrain. Here's my terrain. Let's make it larger. That's Alt W, and I'm going to create a crowd object. So helpers crowd object over here, and I'm going to create a delegate over here. So now let's see, I want to have 100 delegates, and I want those 100 delegates not lined up as I did it before by copy them. I want 100 delegates evenly distributed on the surface of this plane. Inside the crowd object there is modify. There is a scatter function, and the scatter function is the same function actually as the where is it? There is also a tool, edit. I have not used that in a long time. Tools. Yeah, doesn't matter. There's a line and yeah, spacing somewhere. Okay, let's try the, oh, sorry, it's not here. It's under scatter. It's under scatter, so that's one of the extended primitive scatters. The compound object, somewhere here. Okay, there. But let's go for this one. Modify scatter function, and it opens in a little window. So, and here is which object do I want to clone? None. I want my delegates to clone, so it opened here in the window, and I want my delegate to be cloned. How many times? I want 100 copies. I want copies, and where should they be cloned? So at the end you hit generate and then it creates them. Position, I want them on a surface. Which surface? None. It always opens on my other screen. On the plane. So it opens on the plane. And rotation scale, actually I don't care too much. So let's create the clones and do the positions. Okay, and scatter. So there it is. Now I have, oh, did I hit OK? Oh, I didn't. No, sorry. It's all still here. Delegates 1. How many? 100. Position. Surface. Sorry that I have to do it twice. Okay, defined on surface, all ops, clones, positions, scatter, and okay, so now they are scattered. So here they are, 100 delegates now here in my window. The next thing is now my behaviors. Had nothing to do with behaviors, they're just objects, so you can as well take one and move it, delete it, or something else. They're just evenly distributed, or approximately evenly distributed. Let's get my crowd object and create a new behavior. And the two behaviors I would like to use is the first one to just walk around, and this is the wander behavior. So you just want them to wander around. There's not much to do. You can just type in how many times they change their position and so on. So let's just leave it as it is, the wander behavior. And the second behavior that we need is a new, and that is the surface follow behavior, because we want them, when they walk around, we want them to stay on the surface. We have some mountains here, so surface follow behavior. Of course, you have to tell him which surface. None, this one, plane 1. Okay, so we got two behaviors. We got 100 delegates. Let's go for the multiple delegate editing first. Let's make sure they're all allowed to use a 3D space. I'm going to select all delegates here. First one, shift, last one. And they all, let's give them different speeds so it makes it more interesting. Again, the same thing between 2 and 5, and they are allowed to they are no more constrained to X and Y plane. That sounds good. Apply, edit. So now they all have the same parameters, random speed, and allowed to leave the 3D space. And here we are at behavior assignment, where we create a team of all delegates. So new team, all. Okay, all there. I got team 1, wonder behavior, assign. Oh, team 0, wonder behavior, and team 0, surface follow, assign. So now I've assigned both behaviors to my objects. Now I want a little bit more than 100 frames, so let's do the same thing as before. Pile 25 frames per second, and let's do 200 frames. And also the start and end of my solve, I'm going to make it 200, otherwise it will only solve 100 frames and then stop. Okay, that's it. We got the behavior created, we got the behavior assigned to my object. Let's solve it. It will be a little bit slower, but you can see our objects are now moving around. If you do an animation like this, it's also good once you scatter your objects not to use it from the very first frame, because at the very beginning they all look in one direction, but as soon as you go 1 or 2 frames into your timeline, they just have a random rotation because then they start to use the wonder behavior. Also, it sometimes happens that one delegate just does something out of the order and leaves the surface and just wanders off. That also happens. Then you can later on just delete it. And if you look from the top, you'll also notice that a lot of delegates are sitting at the edge. That is also clear because every time they are on the edge, they suddenly can no longer, you know, when they do random left or right turns, then the turns in one direction are always ignored, because you cannot turn outside the surface. So that means actually just half of the time they just walk straight ahead. So that's why a lot of those delegates are sitting at the edge. But the rest is a kind of random movement. You can see how it looks like, how they move around like ants. And if you follow one delegate, so if you click on one delegate, it's quite funny to watch his path. How can you make a path of an animated object visible? Simply by selecting it and then go to motion, and here is motion path, and that shows you where the object is going, but that is for every animated object. And as we have an animation key for every frame, we got lots of keys here. The colors, by the way, show you the speed there at a certain point, and you can also see the handles at every point. So that is a really smooth animation. Now I only selected one. If you select more than one, then you'll get a really nice a pattern of movement. This pattern, by the way, you can also turn it into path that they are actually renderable, because if you render one picture, let's just hit render once, you'll notice that the delegates are not renderable. If you want to see them, you know, like little balls or something, ants moving around, you have to assign geometry to them and link it, because the delegates alone, they are not renderable. So a delegate, when you select it and you watch its object properties, then you see that it's not renderable. It's a dummy, just like this. So you don't need to see it. Every dummy is not renderable. So, but if you want to see the path of the object, you can select all delegates. Let's just select all delegates quickly. So delegate 1 to delegate 100. Okay. By the way, if you're always selecting something like all delegates, it makes sense to create a selection set. Just hit it, call it all, and whenever you need to select all delegates, go to your selection set, all, and then they're all selected. Motion path 200. So let's go for 100. So every second frame is 100. 0, 2, yes, here we are. And now we have, see those lines, they represent the path of all the delegates. If you look from the top, the pattern is actually quite dense, so there's not a lot of areas where they don't reach. But you can see at the edges it's getting much more much more dense. Can you render what I just selected? This piece here, of course you can render it. It's a line, so you can either give it a certain thickness with a modifier, with a renderable spline modifier, for example. Renderable spline modifier. That will take a minute. Yes, because it gives the geometry a thickness and with 12 sides. So let's just do 4 sides. That's much faster. And the thickness is less than that. It's maybe 0.1. Yes, and there it is. And that can be rendered as well. Let's go into a P for perspective. And if you hit render, it will render the network. So just like the particles that we had with the PF spliner app, not app, the script where we can follow the path of the particles, in crowd simulation we can much easier follow them by just selecting a delegate and going to motion and look at the motion path of the object. And you can also convert it into a line. Good, so that was a few simple behaviors and how to assign them. If you look at your crowd object, there's much more behaviors, of course. You can create all kinds of other behaviors with surface to arrive on a surface, different speeds to follow a path, always be oriented a certain way, repel from a wall. There's also a space warp behavior, how you can repel it from any object that has a certain irregular form. So, and you can also stay away from the wall or seek the wall, getting closer to the wall and so on. And with all that, you can create a lot of behaviors. And in addition to that, you can also do scripted behaviors. This is where you can write your own script of how the behavior looks like and so on. Objects like this can also, the delegates can also be linked to bipeds, to like skeletons, and the skeletons can use motion capture data in order to walk. So when they walk straight, they use a certain motion capture data, and when they turn around and turn left or right and stop. So that is all possible in the crowd simulation. I know it's not the most sophisticated tool that they use in feature films. There's different ones. Very famous one is Massive, for example. It's called Massive, and it's a crowd simulation tool they use in feature films. But it's quite a nice tool to create some nice geometries here for once. The wander behavior, the paths like this, and also some fun applications if you want to like do evacuation studies of how delegates leave a certain space. You can also not only make them run on mountains like this, but you can have them run on a floor plan, for example. You can bring in a floor plan. You can, usually when there's a wall or something that you should avoid, I just cut a hole into it, and then they cannot walk there, and so on. So a lot of applications for you guys to play around. I hope you liked it. Don't forget to hit the like button. Any comments, please put them in the comment section. And thanks for watching, and I'll see you in the next one.